In this video, you will learn how to design superelevation for horizontal alignments for CE354 project. Today we will start with the last section of the horizontal alignment design, which is named by the superelevation, and this section actually represents the last part in the CE354 project, highway project. Here, first, what's meant by the superelevation? The superelevation is usually designed for the horizontal alignments. So we have two horizontal alignments and we have to design the superelevation according to these alignments. Now what's meant by the superelevation? As the road comes from the straight manner and goes into the horizontal alignment, in this case the road must be turned with specific angle in order to prevent the slide of the cars out of the road for a specific speed. And then at the end of the first horizontal alignment, the superelevation ends and the road goes in the same manner for the second horizontal alignment. So actually what's meant by the horizontal alignment, if we consider the road in this manner, okay, this is the road. Now we have like the grade for both sides of the road, the first one and the second one. According to Turkish standard, this grade is taken as 2%, but 2% down. This is the grade of 0 and this is the grade of 2%. Why we use this grade? This grade is used for the roads in order to collect the water that comes from the rains or from any other source. As the road comes to the superelevation, at first the road will be in this manner. If we consider this is the outer side of the road and this is the inner edge of the road, then the outside starts to go up, up, until it comes with the same manner with the inside edge of the road. Then both sides starts to rotate around the center of the road in this manner until they satisfy the angle of the superelevation. Then after this, they go back until the inner side comes to the -2 or 2% down grade, and then the outside completes until it comes back to the 2 grade down, and then the road goes in the straight manner again. So what do we have then? How to achieve this superelevation or the design of the superelevation? Now here, if you look here, we have the superelevation. At first we have the design speed 70 km per hour. The radius is 250 meter. According to Turkish standard, we can apply these two equations in order to get the values we need in the computation of the superelevation. So first, we have the value of E here, which is the grade of the superelevation, and it's 0.00443 v square over r. So that means E equal to 0.0044370 square over 250 and 0.086. So we use E equal to 9%. This is lower than 10%, so satisfied, okay? Then we come to the length of the vertical or the length of the superelevation. As L equal to 0.03, 54 times 70 cube over R from this equation. And L equal to 48.57 meter. So we consider L equal to 60 meter. Always we round the length of the superelevation to the next number that's divisible by 3. So we have 48. You can consider, by example, 54, or you can consider 60 meter, 90 meter, whatever. I considered L equal to 60 meter. Then, here, this is related to the superelevation computations. First, we have the road, or the section in the road, and we have the plan of the road here. Starting with the section, as we said before, at first, we have the outside edge and the inside edge with the grade of 2 down in the roads. Then the outside edge starts to go up for the grade of -1, then the grade of 0, +1, until it comes to the grade of 2. When it comes to the grade of 2, it will be on the same line with the inside edge here. Okay? Then, after this, both of them, the outside and the inside edge, starts to rotate around the center line of the road with each other until they come to the specific grade, which is the 9%. Why did we take 11% here? Because at the outside edge goes from the -2 grade until the +9 grade, the distance or the grade difference here will be 2 plus 9, it's 11%. According to this, we can say that the outside edge range is 2% plus 9% and equals to 11%. So the required distance for 1% range of superelevation, we take the length of the superelevation, which is 60 meter, and we take the 11% here, we take it in percent, and it will be 5.455 meter. What does it mean? It means that now to achieve the superelevation, the required one, that means the 9% here, okay, from here to here, with a distance of 60 meter, the length of the superelevation, we have to divide the road into, again, sections, and we take the distance that's needed for only 1% difference in the height, okay? We computed this distance as 5.455 meter, and according to this, what to do then? So, now, it's very important to mention here, look, the superelevation length is 60 meter as we computed before, but this 60 meter is divided into two sections or two parts. The first one is in here, starting on the tangent of the road, we have the distance of 2/3L, so 2/3 times 60, 40 meter. And then on the horizontal alignment, we have 1/3L. That means here we have 1/3L and equal 20 meters. It comes until here. So 20 meter plus 40 meter, this is equal to 60 meter, which is the length of the superelevation. The length of the superelevation, 2/3L on the tangent of the horizontal alignment, and third of it on the curve of the horizontal alignment. Then we have to divide the length of the superelevation into sections or parts that each part equal to 5.455 meter length. Okay, so if we take 60 divided on 11, it will be 5.455 as you see. So we have 11 sections, and according to this, starting from this point, which is 0 point here, here we have the first one, and this is second, so this is 0, and the last one will be in here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. What to do then? Now here, the section of the road at the 0, we are coming into the superelevation. So the section will be like this. If we say this is this one, the first side, and we have here the second side. As we say, this is in negative 2, and this one in negative 2%. Great. Then after this, as we are going into the superelevation, this one again, this point will be minus 2%, but here this one will be minus 1% because the outside edge is going with the difference of 1%. Then here again minus 2%, and for this direction the outside edge will be in this case 0%. After this again we have minus 2%, and here we have 1%. Then we have minus 2% and plus 2%. This is minus 2, and this is plus 2%. Okay. After this is the center line of the road. The both outside and the inside edge of the road will rotate with each other, so with 1% difference. Here we have 3%, then we have, sorry, it's 4%. Five, 6, 7%, this is 8% until we achieve the required superelevation 9%. So we achieved at this point the 9%, which is the required rate of superelevation. What to do then? We take these stations downward to show the section of the superelevation as if we consider it here the center of the road, this is the center line. Okay. Then so again 0, 1, same points. Here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. What do we have here? The inside section or the inside edge of the road, it's minus 2, minus 2, minus 2, and minus 2 until here the fourth station will be with the same grade minus 2, and then it will be minus 3, minus 4, and so on. So until this 4 station we have the minus 2 grade. So we can take it directly with this line. Let's draw it in blue. in order to distinguish the lines. Okay. And then it starts to go down. For the outside one, it starts with the -2, then -1, then 0. So from this point and going on, the height of the outside edge differs for each station. Okay. So how much it differs? Now actually we have the width of the road is 10 meters. For each side we have 5 meters. So as we have here the distance is 5 meter, as we have a change in the grade with 1%, that means for each station 1% we have 5 times 0.01, which means 1%, and it equals to 0.05 meter, that means 5 centimeters. So we have difference in the height of the edge, either the outside or the inside, 5 centimeters for each 1% difference in the rate. So according to this, for the inside, it remains as -2, -2, -2, -2, and -2 for the fourth station, so it will remain on the same line. But for the outside station, -2 to -1, we have 1% difference, so we have 5 centimeter difference in height. So we can take it directly, starting from this point. This will be, again, 5 centimeter difference, 5 centimeters in here. Until this point, we have 10 centimeter difference. Now first, we can say that here the depth is 10 centimeters. Why 10 centimeters? As we said, for 1% we have 5 centimeters. For 2% we have down, because it's minus, so it's down 10 centimeters. Now the outside edge goes up. So according to this, we can connect them all together. This line represents the outside edge, okay? For the inside edge, it goes with the 10 centimeter depth until the fourth station. Then after that, for each station goes downward 5 centimeter extra. So in this manner, here it will be in this point. And because of this, we can represent the inside as in this manner. This is the inside edge, okay? So here we have 5 centimeters until here. It goes up by 10 centimeters and comes to 0 line. This is the center line in here. Then again, it comes with 5 centimeters. Here we have 10 centimeters, 15 centimeters, 20, 25, 30. This one is 35, then 40, and finally 45 centimeters, okay? That means the outside edge until the end of the superelevation, it comes to the height of 45 centimeters over the center line of the road. For the inner side or for the inside edge, we have 10 centimeters. Again, here 10 centimeters, 10 centimeters, 10 centimeters until here. It's 10 centimeters. Again, we have 15, 20, 25, 30, 35, 40, and 45 centimeter. So by this, the design of the superelevation is completed. So in the superelevation design, again, we have to compute the rate of the superelevation, the length of the superelevation, and then we have first to draw the section of the road, the plan of the road with the change in the rate, and finally we have to draw the plan of the superelevation representing the outside and the inside edge of the road in this manner. This design of the superelevation can be applied for both horizontal alignments we have in our road. The first horizontal alignment and the second horizontal alignment. In the next video, final steps of highway design will be applied on the plan.